Hello guys. So I welcome you to the another lecture of the binary heap series. In this lecture we are going to talk about the extract minimum and extract maximum function. Okay. So previously we talked about the decrease key function. Okay. We talked about decrease key function, right? Decrease key function, which is used to decrease the value within a min heap, right? Within a min heap. Okay, so we talked about this. We also talked about the code of the max heapify function, right? The program, example program of the max heapify function. Although I told you already about how it would work, but again, we saw the program for this max heapify function. In this lecture, we are going to talk about extract minimum and extract maximum function. Okay, now what are these extract minimum and extract maximum function? So extract minimum function, talking about the extract minimum function, why is it used? Okay, so this function is used to extract minimum value, or you can say the topmost value, right? Topmost value in a min heap. Okay, since I told you that min heap has the topmost value as the smallest value. Okay, so to extract that value we are going to use extract minimum function, and similarly extract maximum function. Okay, extract maximum function is going to be used. Okay, this is a function to extract max value or maximum value. Okay, or you can say topmost value of a max heap. Okay, of a max heap. So yeah, these are the purposes of extract minimum and extract maximum function. Now first we are going to look at how the extract minimum function is implemented. Okay, and then we are going to look at how the extract maximum function is implemented. Okay, so in order to when we're talking about binary heap, we always represent it in the form of array, right? So let's suppose we have a binary heap uh, of capacity 5. Okay, we are not talking about size, we are talking about capacity. So if it is filled, then only will talk about size. So let's say this index is filled, first index is filled, then it will have size 5. But initially it is having size 0 and capacity is 5. It can store 5 elements, but it hasn't any element at any particular index. And let's say the heap looks something like this. Okay, so this is what the structure of heap looks like, since it is having only 5 elements, right? So this is index 0, this is index 1, this is index 2, this is index 3, and this is index 4. Okay, now you know how we write the extract minimum function. Okay, so it is going to be an integer function, since it is going to give us the minimum value or maximum value within a max or min heap. Okay, so let's say first we will talk about the min heap. Okay, we'll talk about the extract minimum function. Okay, so let's say int, and then let's say extract minimum. Okay, we are going to implement this function. Okay, how it works. Okay, so there are conditions that we need to look at. Okay, so the conditions. Okay, conditions, when we talk about conditions, so conditions for extract minimum. Okay, extract minimum. Okay, to extract the minimum value we have certain conditions. Okay, so the first condition is that size of min heap is 0. Okay, size is 0. What it implies, there are no elements in the min heap. Although it has it has the capacity 5, it can store 5 elements, but it is not having any elements at any particular index. So the size of the min heap is 0. In this case we'll return some value which will tell us whether the size is 0 or not. Okay, so we'll return -1 here, because the return type of the function is an integer return type, right? Second case that we're going to look at is the size of min heap min heap is 1. Okay, if it has size 1, only one index is filled, right? So this, if it is only one value, then that value is only considered as the minimum value. So what we'll do, we'll reduce the size. Okay, we will reduce the size, and then what we'll do, we'll return ARR of size, because since now size has become 1 lower than the previous. Earlier, let's say it was having size 1, then size represents 0 after reducing it by 1. So at the 0 index only the element will be present, right? Yeah, so this is why we are returning ARR of size. Okay, and the third condition is that the size is greater than 1. Okay, greater than 1. Okay, for that case we have to handle it separately. So what are the conditions? Okay, let me tell you. Okay, so in the first case, if we'll check if size, okay, if size is equal to 0, in that case what do? We simply return -1. This -1, if we get as the output, it will imply that the min heap has no element or has the size 0. Okay, this will implies size 0. Okay, another condition, this is a comment. Okay, this is a comment and it is not going to be executed, uh, or compiled, you can say. Another condition that we're going to look at is if size equals to 1. Okay, in that case what we do, we reduce the size. Okay, and then we return arr of size. Okay, and the last condition, in the last condition what we do, we swap the element at the first index. Okay, because that will be the minimum, right? The element at the top index will be the minimum. So yeah, so the element at the first index will be the minimum, sorry, 0 index. Okay, so what we'll do, we'll swap this element here with the last element, then we will reduce the size so that this is not considered in the heap. Okay, then we'll call for the min heapify of this particular node so that the value goes to the correct position, okay, within the heap, and then finally we'll return the element. Okay, so what we'll do, we'll swap first. Okay, swap arr of 0, the first element with the last element, arr of let's say size -1, because that size represents the number of elements while size -1 represents the index of the last element. Okay, then we will reduce the size. Okay, then we'll call min heapify for the first element, because there might be conditions where the first element should not remain at the first position, so we'll call min heapify for the first element, and then we will will simply return arr of size. Okay, yeah, so this is what this is how it looks like. Okay, extract minimum function. Now let's use it. Okay, let's use it. So let's suppose we have values here. Let's say this is a min heap. Okay, so -5, then -3, 7, and then 9 and 11. Okay, so all the nodes have child value greater than all the nodes having child's value greater than the node itself. So -5 is lesser than -3 and 7, and -3 is lesser than 9 and 11. Now let's represent it in the array: -5, -3, 7, 9, 11. Since the size is not 0, so this part is not executed. Since the size is not 1, so this part is also not executed. We directly move to the last part. Okay, we'll talk about all the conditions. Okay, here I'm talking about the third condition. Okay, this condition, when the size is greater than 1. Okay, we are talking about this condition. So what happens is that we swap arr of 0 with arr of size -1. Now since it has size equals to 5, it has capacity as 5, but since all the indexes are filled, so it has size also as 5. Okay, now we will swap arr of 0, okay, 0 with arr of size -1. Size -1 is 5 -1, which is 4. Okay, so we are going to swap these two elements. Okay, these two elements. Okay, so let's swap them. Okay, let's erase them. Okay, -5 and 11. Okay, so 11 goes to the first position and -5 comes to the last position. Okay, now we reduce the size, so size becomes 4. We call min heapify for this particular node. Okay, now this node is not considered since it has index 4, and since the size of the min heap is 4, now it will only consider this part. Okay, this part within the min heap. Okay, this part. So now our heap looks something like this. Okay, let me write it here. Okay, so heap looks something like this. Okay, only this part is within the heap. This node was removed. Okay, since we reduced the size, so the node is also removed. Okay, now we have only 4 elements, right? So let's say 11, -3, 7, and 9. Okay, when we call min heapify for now we are calling min heapify, right? We call min heapify for the index 0. Okay, so you know the implementation of min heapify and how it works. Okay, so what will happen, it will find the minimum of these three. Okay, so this is I equals to 0, this is I equals to 1, this is I equals to 2, this is I equals to 3. Okay, so minimum is minus 3. Okay, so what happens is that smallest will become equal to 1. Okay, now we are going to swap. Okay, we are going to swap. So what happens, minus 3 goes there and 11 comes to the second position. Okay, so after the first operation, okay, let me create another. Okay, after min heapify of 0, okay, when we perform min heapify of 0 this way, this thing, we get a new heap. Okay, we get a new heap. Okay, and the new heap is going to look something different. I equals to 0, I equals to 1, I equals to 2, I equals to 3. Okay, but this is not the final heap. Okay, minus 3 comes here, 11 goes to the index 1, 7 and 9 again at this level. Okay, again the swapping is going to happen, and the final heap, okay, here we will call min heapify of I equals to 1. Okay, of this 1. Okay, if I'm right, if I'm if yeah, so I becomes min heapify is called for the large smallest, right? Smallest is 1. Yeah, so min heap after the final heap is going to look something like this. Okay, yeah, so this and last node. Okay, so the final heap is going to look something like this: minus 3, 9, 7 and 11. Now it represents a min heap, right? Min heap, because each node has the value lesser than its child nodes. Minus 3 has the value less than 9 and 7, and 9 has the value less than 11. Here 11 has the value greater than 9, so it was not following the min heap property. So finally our heap looks something like this after removing the minimum value, uh, which was obviously minus 5, right? Which was obviously minus 5. Yeah, so this value we removed, right? We minus 5 value was the smallest, so this value we removed. Finally what we'll do, we have called minheapify function, and now we're going to return ARR of size. Okay, ARR of size has now become 4, so ARR of 4 is nothing. Okay, here I have written the wrong index, so this should be 4. Okay, so ARR of 4 was 11, right? So 11 gets sorry, ARR of 4 after after swapping it became minus 5, right? Then it was removed, so yeah, we'll return minus 5 here. Okay, return minus 5. This ARR was not changed, right? So minus 5 is going to be returned. Okay, return minus 5. So this extract minimum function, if we're going to call for the first time, it will give us minus 5, then it will give us minus 3, then it will give us 7, then 9 and then 11. Okay, this is how it is going to work. Okay, so yeah, this is all about the min heapify function. Okay, let's try to implement it. Okay, let's try to implement it. Okay, so we are going back, minus 5, minus 3, 7, 9, 11. This is the heap. Okay, so let's call it extract min. Okay, extract minimum dot cpp. Okay, now let's copy the code. Okay, previous code, so that we don't have to. Okay, yeah, so let's create the array. Okay, so let's say we have created a min heap of 5, size 5. Okay, now the min heap looks something minus 5, minus 3, 7, 9, 11. Okay, so yeah, we will change this heap only. Okay, minus 5, then minus 3, then 7, 9, 11. Okay, the rest of it is all fine. The size has become 5. Now we are not going to call decrease key function here, rather what we are going to call extract minimum. Okay, min heap dot extract minimum. Okay, and since okay, haven't implemented it yet. Okay, I'm going to print it because it will return an integer value, and we can directly print it. Yeah, so for the first time it should give us the value minus 5, because that is the smallest value, right? So this is going to be the implementation of the extract minimum function for for removing the minimum value from the heap. Okay, yeah, so now you'll see how it works. Okay, so it shouldn't be void, it is going to be int, because integer heap I have created, right? Int min heap. Okay, not min heap, actually the name of the function. Okay, let's say we don't pass it anything, right? So if size is equals to 0, then return, okay, return -1. This will represent, okay, represent the heap is empty, okay. Yeah, if size is equals to 1, okay, in that case what we're going to, we are going to return, we are going to first reduce the size, okay, then we are going to return, okay. So first we reduced, return ARR of size, okay. Now finally, for the last, what we'll do, we'll use swap ARR of 0 for the last condition, okay, ARR of size -1, okay. We reduce the size, okay, okay. We call the min heapify for the first position, which is 0 obviously for the root, and then we return ARR of size, okay, ARR of size. Yeah, so this is how it is going to work. Now let's call it, okay. So we are going to call it here, okay. So it should return us -5, okay. Let's see. Yeah, it is returning -5. Now we have extracted my, the minimum value -5. It should return us -3, okay. So it should give us -5 and then -3 because we have used, spaces here. Or let's use new line here. Let's see what we get, okay. -5 and then -3 because the second minimum is -3. So this is how extract minimum function works, okay. Now talking about the extract maximum function, it is just, it has no difference. Rather, the only difference, with the max heapify function is that we called min heapify here. Rather than this, we are going to, call for max heapify function here, and that is the only difference with the max heapify function, okay. So let me tell you what max heapify function will do, and then we'll end this lecture, okay. So simply, let's say we have a max heap, okay. We have a max heap, okay. So let me draw a max heap for you, okay. So let's say this is a max heap of size 5, okay. So this will have index 0, this is going to have index 1, this is going to have index 2, this is going to have index 3, this is going to have index 4, okay. Now let's say the value is 11, 7, 9, 3, 5, okay. So all the nodes have the value greater than the child. So 7 and 9, the parent of it is 11, or having value 11, and 7 having child with value 3 and 5, which is smaller than the node itself. Now in the array representation, okay, okay, so array representation of this max heap would look something like this, okay. Yeah, so 0, 1, 2, 3, 4, okay, 11, 7, 9, 3 and 5, okay. Now what happens in the max heapify function, the only difference is, okay, the only difference is that in place of min heapify we are going to call max heapify, and it would return the maximum values. So first it will return 11, then it will return 7, then it will return 9, then it will return 3, and then it will return 5, okay. So let me just implement the, function for you, okay. So the function would look something like this, okay. Implementation of the, okay, max heapify function, okay, to extract, sorry, not max heapify, actually extract maximum function, okay, to remove the maximum element, okay, from the max heap, okay. So void, let's call it extract maximum, okay. We don't pass it anything. So if size equals to 0, in that case we return -1 here as well, okay. Return -1, okay. If size equals to 1, we reduce the size, okay. Same, okay, it's just same, and we return ARR of size, okay. If you know what is wrong here, hmm, if size is 1, okay, I should change the return type, right? That was the only, yeah. Otherwise there is no if. Now we are going to swap ARR of 0 with ARR of uh, size minus 1. Okay, then we are going to reduce size. Okay, then we are going to call max heapify. Okay, heapify here of 0. Okay, and then finally we are going to return error of size minus 1. Let's create the max heap as well. Okay, so let's say, let's erase this off. Let's comment it out. Now let's create max heap. So let's say heap max underscore heap of size 5. Okay, let's create the same max heap. Okay, max underscore heap dot arr of 0. Okay, equals to, okay, so this is going to be index 1, this is going to be index 2, this is going to be index 3, and this is going to be index 4. Okay, now let's give it the same value. Okay, 11 7 9 3 5. Okay, so or 11 9 7 3 5. 11 9. Okay, sorry, 11 9. Okay, 7 3. Okay, and 5. Okay, this is how the okay, or we can write it 7 also, and 9 will be here. Okay, so in the second case we can get 7 as well. Okay, though it is not the maximum at the second position, but it is maximum at the second level, right? Okay, so upon get calling max heap dot extract max. Okay, so upon printing this, okay, okay, what we are going to get, we are going to get 11 first. Okay, so let's see. Okay, so we haven't fixed the size, we haven't used insert function here. Okay, so size will not increase automatically, so we'll have to increase the size. Max underscore heap dot size is going to be 5 now. Okay, now let's see. Yeah, so we are getting 3. Okay, so what is wrong with this? So let's check. So max extract max is 0 1 2 3 and 4. Okay, 0 1 2 3 and 4. Okay, 3 5. Okay, so what we are doing wrong, let's check. Okay, size is 1, we'll reduce it, otherwise we'll do this way. Okay, error 0, size decreases. Okay, this is not size minus 1, actually this should be error of size. Okay, yeah, now we're getting 11. So this was all about the min heap, extract minimum and extract maximum function. Yeah, this was all about this lecture. Hope to see you in the next one.